Good morning. I think it's time to start. Um, Good to be here. I have never been to Kiev before. I hear it's a beautiful city. Unfortunately, I won't have time to check around. But hopefully you guys will invite me next year, and then I'll have more time to see all the wonderful things that are in here. My name is Mishko Hebri. I work for Google, and my job at Google is to, well, it used to be, and now I have a different job. It used to be to go help other projects get better at writing code. Specifically, to help them at getting better at writing tests, because we believe that tests is the way to get to writing better code. So I was kind of an agile coach, and the way this used to work is that there was a project, I would go and join a project for 6 months or something like that, and I would work with them on refactoring it, and kind of showing them how tests can be helpful in writing good stuff. Anyways, about 2 years ago, I said to myself, you know, helping people is nice, but I really want to build something. And so, actually, for the last 2 years, I've been working on a project called AngularJS. How many of you guys heard about it? Awesome. So I'm going to have another talk later on today about how we use testing with AngularJS to make something as complicated as AngularJS possible. Anyways, in the meantime, let's talk about testing in terms of psychology, in terms of how do people think tests are written. So there's 3 things you need to know about testing. Anybody know what they are? Well, the first thing you gotta learn is to learn to read the code. I know it sounds kind of strange because, hey, I've been writing code for such a long time. Why would I need to learn how to write it, right? Or read it. Remember Matrix? Have people seen Matrix? All right. It's a good movie, right? So in the Matrix, there's this scene where these characters are falling down and everybody plugs in the back of their head and they kind of see the world. And the people who've been doing this for a while, they say, I don't need to plug in, I can see the characters and I see there's a beautiful woman walking by. Have you seen this scene you know what I'm talking about? Okay, so the point is, people have been trained to read code for what it is, in terms of like what it does. But I want you to suspend that for a second and look at the code as a structure. And this is hard because, you know, I don't know how many years you guys have been writing code, but I'm assuming it's 10, 20 or something like that, right? If you've been writing code for 10 or 20 years, you are naturally conditioned to read it and try to decipher it in terms of what does it do. But that's the wrong thing to do with respect to testing. You don't want to decipher what it does, you want to understand how it's structured. Because testing is a function of structure, not what it does. The second thing you got to keep in mind, that testing is all about managing your dependencies. Now there's lots of different kinds of dependencies, and we'll get into that. But it all comes down to understanding dependencies between your code and trying to break it down. And the last part is your environment. And specifically, there's this old joke that says, you know, there's a guy chopping down a tree, and this consultant walks by and says, you know, if you sharpen the axe, you'll chop it down faster. And the guy says, I don't have time to sharpen the axe, I'm too busy chopping down a tree. So it's the same thing with testing. That is, yes, it takes time to set up your environment so it's easy to test, but then hopefully it will pay dividends. So why test? Well, I write tests because for me, it's easier to run a test than it is to run the actual application. Because I'm lazy, right? And I'm assuming everybody of you guys are lazy too, right? You want to do the least amount of work to get the most stuff. So I write tests and I run the test because when I set up my environment, and by the way, in my second talk, I will show you how to set up your environment, is literally easier to run the test because when you set up the environment, the test is as simple as hitting the save key. For example, my tests execute every time I hit the save key, which I'm sure you guys do all the time, right? So if it's so easy to run the test, then why would I actually launch an actual application? Keep in mind, the launching application is running a database, running a web server, opening up a browser, navigate through a whole bunch of menu systems before you get in, log in, etc. It takes time for all these things. The second thing people say is, hey, you know, this test stuff sounds good in theory, but it actually takes a lot of time and effort to do. These are actual numbers I collected when I was working at a particular project. And this was a JavaScript and Ruby backend. And so it kind of breaks down different things. But the important thing to pay attention is this line over here. This is total lines of code. And I broke this down into lines of code of production and lines of code of test. And so it's approximately 1-to-1. I mean, there's a few less tests than production. I guess I've been slacking. Usually you want to aim for about 1 to 1. And so you say, well, if you have twice as much code to write, wouldn't it take twice as long? Right? That's kind of the assumption people work under. And they oftentimes use it as a counter argument to saying why writing tests is a lot of work and I don't want to do it. But it turns out I also kept track of the amount of time I spent on this. And so I spent about 1,000 hours on actually writing the code, but only about 120 hours on writing the test, so about 10%. Now how can it be? How can it be that I have to essentially write the same amount of lines of code in production and in test, but yet I spent a fraction of the time worrying about test? And the reason for that is this. This is a typical, on the left-hand side you have a typical piece of production code, and the right-hand side is a typical test. Now the font is too small intentionally because I don't want you to read it. But I want you to look at the structure of it. And I want you to notice how the code on the left meanders, right? Goes back and forth. And what does the meandering mean? It's indentation, right? We know all that means. That means every time I have an if statement, for loop, while loop, all the conditional stuff in our application causes indentation, right? That's why the left-hand side is like that. The right-hand side doesn't have any. It's a straight sequence of things. That's what makes the right-hand side easy to write and the left-hand side complicated to write. It's the indentations, right? The if statements. And so the right-hand side is just a test that basically says, if I do this, I expect that. There is no if statement in there. There's no for, while loop, there's nothing. And this is why it's easy to write and explain. But then you go to the left-hand side, and then you're scratching your head, like, how do I get this behavior? Let me try putting an if statement here. Oh, that breaks this other thing. Let me refactor. Let me take a different approach. Like, you've all gone through this, right? And you know that there are times when you rewrite a function 10 times over before you get it right. And this is what makes the left-hand side difficult. Now, how do we write code? Well, we all write it this way, right? The red stuff is where we put the bugs in. The green stuff is where we take the bugs out, right? Everybody works this way. And the way most people do this is they test it out manually. And so the only thing we're talking about is instead of doing it manually, we want to automate it. Now, I know it's easier said than done, but really, fundamentally, everybody works this way. And this is why I think this is not what the waterfall model suggests, right? Nobody writes a design ahead of time and then codes it all in one shot and tests it all in one shot, right? It's an iterative process where you can keep going over and over, and you get these happy points where, like, I think I'm in a good point, and you check it in. And I've never seen anybody do anything but this. And this is essentially what iterative development is about. Now, testing is not like frosting. What does it mean? You cannot, if you're baking a cake and you forget to put sugar into the cake, and then you try to put the sugar on top, it's not the cake that you're looking for, right? It just doesn't taste good. The testing is the same exact thing. People have this idea that they can write code, and then after the fact, they're like, oh, I'm gonna write some tests. Doesn't work. I've seen this done many times over, and it never is the right thing. All it ends up doing is leaves people grumpy, and they walk away and says, testing, that's BS, I'll never do it again. So testing is something that has to be baked in from the very beginning when you're writing your code. It's a fundamental part of writing the code. And so people give you lots of different excuses why they don't write tests. And some of them are semi-valid, like the fact that I have a legacy code base and it's not very helpful. I mean, it's not very, the code base is not helping in writing the test. The code base is fighting with me, and I'll show you why that is in a second. Or they'll say, I'm testing UI, which is harder, and I'm not saying these are valid excuses. I said in the corner they're semi-valid. Like, I get it. Like, if you have one of these issues, it's harder, and you have to be more creative about how to write tests, and so I'm more forgiving. But the stuff on the bottom, that's pure misconception. That's just not true. Tests helps the design. Tests catch bugs. Writing tests actually makes you faster because it's literally faster to run your code. And it can be exciting, and it makes it easier for you to change things and so on. But there's a big excuse in the red box that I haven't put in there. And I'm curious if you could tell me what's the excuse that I would consider valid, but nobody ever says that. Nobody ever comes to me and says, Mishko, I don't write tests because X. What is that X? Anybody? Nobody ever says that, by the way. I didn't know. You seen this presentation? No. Correct. Nobody ever comes to you and says, I don't write tests because I don't know how, right? It's like this embarrassment, like, yeah, I don't know how. But this is strange to me because people, you know, if I come to you and say, do you know Scala? You're gonna say no. And if it's an obscure language like COBOL, and I'm gonna say, do you know COBOL? You're gonna be all proud, no! Right? Why is it that we can admit not knowing a language, but we cannot admit not knowing how to test? I mean, what's the difference between the two? Why are we ashamed of one, but perfectly proud to claim we don't know a language? Because, you know, testing is a skill. It's a skill that you have to get across, you know, a lot of different experiences. And so, don't know how is the excuse I would love to get from people, because then they, you know, we can at least make progress. But nobody ever says that. Everybody makes up other excuses. So the way people, this is kind of how people think about writing or dealing with tests. They say, you know, I'm going to have a bunch of software engineers, and they're going to put the bugs in, and I'm going to get QA, and that's going to run the tests. And usually they're manual tests or exploratory tests. And at some point, you know, your QA says, I'm bored of running the same test over and over again. It takes 2 weeks to validate your code base. Can you speed it up? And so you get test engineers, and the job of the test engineers is to automate them, right? And the test engineers try to automate, and they're having a really hard time, and so they're like, if we only have some testing magic at this level in form of tools, we could make our life easier. And so they go out and they go talk to companies, and the companies are glad to sell them all kinds of tools. You know, things like, oh, you run your application, we record all the steps, and we play it back, right? Those are common tools in that form. And so people look for testing magic at this point, and there is none. All these solutions of after the fact of writing tests, they don't work that well. You know, anybody have experience with them? Did you enjoy, I mean, do you think their work, no, yeah. It's just not that exciting. It turns out there is such a thing as testing magic, but it happens up there. It happens with the engineers. And the thing is, the moment you have engineers, a set of people who are responsible for writing code, or to put better, a set of engineers whose responsibility is to create bugs, and a different set of engineers whose job is to take the bugs out, they have different goals, right? It's not the same person. And so if the engineer does something that makes the test engineer's job difficult, he doesn't feel the consequences, right? So if we do something like, oh, I don't know, singletons, we all know what singletons are, right? It's a bad idea, but I don't think most engineers think that it's a bad idea because they don't suffer through them, right? The suffering is done by test engineers. And so unless this person is the same person, there's no loop. Feedback loop, right? All we have is grumpy test engineers complaining how horrible the code is and how untestable it is, and the engineers are all like, looks good to me. Then we need to close the loop, and the only way to close the loop is to make the software engineers be responsible for writing unit tests. Now, I didn't say all the tests, I'm just talking about the unit tests. Now, it would be better if they were responsible for everything, but if you can get them to be responsible for unit tests, that's like 90% of the problem right there, because any mistakes they do in the design of their application is going to be reflected in difficulty in testing. So they are going to be forced to eat their own dog food. And they will very quickly learn that certain things that they used to like doing, like singletons, are actually a very bad idea when it comes to the point of the testing. So let's talk about reading the code. So I do a lot of interviews at Google, and this is my favorite question. I ask two questions on an interview. One is, I want to know that you know how to write unit tests. And the second question I ask is, I want to know that you know how to design a code base. Those are the only questions that I ask. And so, the way I ask do you know how to write tests, is I say, imagine you're an evil engineer, and your job is to make code hard to test. What do you do? Private functions? I have a regex expression for you that fixes all that. That's not the problem.
Reflection.
Reflection is metaprogramming that necessarily makes it hard. Keep going.
Singleton statics.
Singleton statics. Okay, that's a good one. That's a hard one to fix. Any more?
Introduce a lot of
Dependencies. What was I? Complex constructions. Good. Okay, so some of you guys are pretty evil. Well, it turns out that we have this innate ability to make hard-to-test code. Like, nobody teaches us. We don't go to school to figure this out. We are naturally good at this stuff. And we actually have to unlearn, we have to learn how to make it easy to test. And so when I ask this question and people give me these standard answers such as, or I'll show you later on, I know that they have never done testing because the person who really has done testing, the first thing he's going to say is global state. I want to get rid of global state, I want a dependency injection, I want get rid of static methods because they cannot be overwritten, right? That's the kind of person who suffered through it, and those are the learnings he has. Anyways, so let me show you a piece of code. Again, think matrix. And this is the code I give in an interview usually, and I say, refactor this for testability. And I bet you I know what all of you guys are thinking. All of you guys are reading the code and trying to understand what it does, right? How many people are trying to understand what it does? Okay, you all failed. Because, as I said earlier, testing is not about what the code does. I don't care if this launches satellites or if this is a game. This is irrelevant to the question. What matters is how it's structured. And so, the thing to look for is the structural stuff. Now the problem is, as I said, we've been trained, we've been writing code for so long, is that it's all about how do we, what does the code do? Like, that's the first question that comes to our mind. And so I'm going to help you out. I'm going to rename all the variables so that you have no freaking clue what it does. Okay, is it easier or harder to test? Easier? Why? Okay, so I tricked you, right? But that's because of human brain, not because fundamentally anything has changed. I mean, if you think about what the compiler does, compiler really does this, right? It all creates pointers everywhere, and so structurally, this is what's happening in there. And so, is this easier or harder to test? It's the same, and so the question becomes, well, is it actually easy or is it hard? But I'm asking, how would you change the structure to make it easier? Or what are the issues that you see over there?
Well, you got two dependencies on line 2 and 3 in function S.
So you have B and C over here, okay? B and E, B and C.
Yeah, well, yeah, sure.
Okay, those are you. Okay, so this is kind of getting to the heart of it, which is, it looks like this class has dependencies, and looking at the private state is usually a good suggestion as to what the dependencies are. So it looks like B and C are dependencies of the class A, but look what's happening. We don't actually ask for dependency B and C, we're asking for B, right? So it's the old joke where you come to a store and you have to pay for something. And instead of the clerk saying, I need $10 or whatever the local currency is, the clerk says, I need your wallet, and I will take the $10 out. Right? This is exactly what's happening, right? I want B and C, but I'm not going to ask for it. I'm going to ask for something else, your wallet. And from there, I will get my B and C. Now, why is it that when we frame the problem in terms of something that we're familiar with, like objects, we find how ridiculous it is to ask for somebody's wallet, right? Because we know the trouble with giving somebody's wallet is that inside a wallet we have a bunch of other things we don't want other people to get their hands on. But yet when it's in terms of abstract concepts like classes, we're perfectly happy to give people the wallet, which is the D. So I'm going to color code this for you. And it turns out the red stuff is the stuff that I get to control from my test. So if I say new A, I have direct control over D, because I can say new D, or I can say new subclass of D. And inside of the subclass, I can override whatever I want, right? So this is the red stuff is what I have direct control over. Now, I also have indirect control over B and C because I can override the method. For example, in the case of a D, I can override method B and I can then override what it returns in method C. And therefore, I indirectly, through a lot of hoops, am able to control C. And I can also kind of control D because that's like the third level of indirection. And after that, you could keep on doing this forever, but at this point, the levels of indirection are so crazy that like the game's over, like you lost. You cannot figure out what's going on. I mean, you'll have a piece of test code which has like 3 lines of test and 50 lines of setup. Like it's unmaintainable at this point. So the reason why this code is hard to test is because if you say, okay, first level dependency, second level dependency, and third level dependency, this is what you get. And really all the interesting stuff, which is down here, you don't have a control over. So the code is essentially hard to test. So the trick of it is, how do I restructure the code so that I can get hold of as many of the variables inside of this if, or whatever the main block, right, the main logic, as I possibly can. And so that's our goal, is to change it around. Now you can think about it in your head, how you would change it around, but I'll give you a solution. This is the solution. Solution is, ask for what you want. It's a simple concept, right? So you say, well, I need D, E, and F, and as you can see, I'm just going to ask for it. And notice what happens in the constructor. I don't try to do anything with it. I don't try to look for stuff inside of it. I simply ask for what I want, and I write it into my private members. And then inside of my logic, I can see where the second level and third level of indirection is, and I can see that I pretty much can get a hold of any variable I want from within a test. And this is the whole secret to testing. If you understand this, you can be a master programmer who knows how to do everything. Do you agree? Okay. John agrees. I must be right. Let's see. So, I hope what you've learned is that what the code does is irrelevant. And this is the hardest thing about the whole testing thing, is people constantly try to understand what the code does. It doesn't matter. How the code is structured is the only thing that matters for testability. And I'm going to argue that the way you have been structuring your code for all this time, unless you have been writing tests, you've been doing it wrong. Because I know I've been writing code for a very long time, and I've only recently figured out how to write tests, and I realized that all this time I've been doing it wrong. Because it's all about managing the dependencies. By the way, if you have questions, I love questions. Don't make this a boring me talking all the time. I can make it a two-way. Okay, nobody ask questions. So, when I ask people what makes hard to code say, this is what people usually say: make things private, using the final keyword, or having long methods, or being written in French, or something like that. The real issues are mixing the new operator with logic, we'll talk about it in a second, looking for things, doing work in the constructor, because that constructor is something you have to do over and over and over again inside of your test. Global state, the other coin of the global state is singletons, having static methods because you can't use polymorphism, having deep inheritance hierarchies because the constructors cannot be overridden, having too much complex logic inside of your business logic because you haven't broken it up into the right pieces, and a couple of other things. So these are the kind of things that people who've been doing tests for a while kind of innately understand. Maybe they can't put it into a bullet list, but they understand it innately. So what can I teach you about writing tests? Turns out nothing. There's no secrets to it whatsoever. I cannot tell you, this is the magical way you write tests, because there really is no magic to it. All of the magic is in writing the code, right? That flips it upside down the way you look at this problem. All this time, everybody's running around and saying, how do I test this? How do I test this? They're scratching their head. And it turns out that's the wrong question to ask. The question isn't, how do you test it? The question is, how do you make the code testable? Because it turns out, if I give you the code I have written, and I hopefully done it with testing, with testability in mind, anybody can go and write the test, because it's obvious how you test it. Oh, you want to execute this function? Well, instantiate this class, it has some dependencies, map those out, or make the real things. And then the whole thing just kind of naturally falls out, and you have nice, simple tests. So I can teach you good OO practices, I can tell you about dependency injection, I can show you how to do test-driven development, I can tell you a lot about what makes code untestable, but I fundamentally cannot teach you anything about writing tests. Does that make sense? Okay. So there's no secrets to writing tests, there's only secrets to writing testable code. This is the only thing you gotta remember from this talk. So let's look at how people write tests, or how do we get here? So you write some awesome project, and at some point the project's big and you're like, well, I gotta do some testing, sorry, it turns out my computer's not charging. You gotta write some tests, and you have to say, we're having issues, and so you get QA, and you try to automate this stuff. And the first thing that people think when they say write a test is they say, ooh, I know, I will write a framework, because we love to use the word framework, we love to write them. I will write a framework that will pretend to be a user, and I will click around on my application, and that's how I'm going to test. This is the natural first thing that pops into everybody's head. This is what popped into my head when I started doing testing. And it turns out if you do that, you have you'll have a very slow test, extremely slow, because you literally are going through every single page. So if you have something like a Gmail application, your test starts with, let me log in. Or worse yet, the test starts with, let me create a user, let me register with Google, right? And log into the Gmail, and then, oh, the Gmail box is empty, so I have to go and send some bogus emails so that I can play with them, etc. And so all of this setup makes the test super slow, and it also makes it super flaky, because if something fails in the whole sequence of things, for example, if the login page is broken, then you have all of the subsequent tests broken as well, because it's something that every single page does. And so let's call these kinds of tests scenario tests, or end-to-end tests, or large tests. And so when you start this, you're going to realize, hey, the tests are big, they're slow, they're flaky, they're actually not that useful to me because they take literally hours to run, and therefore the engineers can't run it all the time. So what can we do to make it faster? Well, you kind of scratch your head and you say, well, I have an idea. I can refactor the code so that inside of my test, I'm going to use a fake authenticator, right? Instead of trying to log in with the real stuff, I'm going to have this fake one that's going to always pretend to be authenticated, and therefore I can skip this big portion from all of my tests. And what you're doing is essentially taking a large application, you're chopping it up. You're saying, okay, this authentication comes back out. And then you do some more of it and you say, well, the sending of email is super slow, so I'm going to replace that with like a fake backend. And so you're slowly taking all your dependencies and you're replacing them with idealized versions of themselves that are always doing what you would expect. So you don't actually send emails, you're just pretending to send emails. You're not actually logging, you're just pretending to log in, and so on. And you keep chopping this up, and then it turns out if you do this, your tests are getting faster and faster and faster. And they're also getting less flaky because there isn't this whole sequence of dependencies that all have to work. Now the sequence of dependencies is much shorter, so if any one of them fails, it's easier for you to figure out what's going on. So if a test fails and you have a fake authenticator, you're not going to go and try to figure out if the authentication is broken, because you know that's not the issue, right? If the mail is not being delivered and you have a fake mail server, you know that's not the issue either. So you know that you probably are not talking to the mail server or something of that sort. And so you're kind of shrinking it. The nice thing about end-to-end tests is that if they work, you have a very high confidence of what's going on, right? If the test passes, you know that the application kind of works, but you also have this full sense of security, because doing this simple email exercises like 80% of your code base, right? But the opposite is also true, which is that if the test fails, you have no idea where to look. Like, it could be anywhere in your application. And so the test failures are super hard to reproduce. A test can take literally minutes to execute. So if the test takes like 10 minutes and you're trying to debug a step, the last step in the sequence, it's a horrible debugging experience. And so you basically repeat this and you keep breaking the system down into smaller and smaller pieces. Eventually, I'm going to skip a couple of things. Eventually you get to unit tests. And what you've done is you kept breaking it up until you got to the fundamental building blocks of the application, which is the actual classes. And this is where the interesting thing happens, is that when the test passes, you have high confidence that the class or the particular function does what it says. But the opposite is also true, that if this particular test fails, you know not to look everywhere in the application, because you're only testing this one small portion. And so it's almost like you don't even need the debugger at that point, because if there is a method that sorts, and that method, the test for that method fails, I know that I have to look at that method, right? And usually, if the order of items is reversed, and there's like 3 if statements in there, well, gee, I wonder which one is wrong, right? It makes it really easy to figure out what's going on. The other property of this thing is that because you've broken everything down, the tests become very, very fast. And this makes total sense. If you think about it, modern CPUs execute in gigahertz range, and they can literally, there's very little you can do to keep a modern CPU busy for an extended period of time. The reason why your application is slow, I'm going to make a crazy statement, is that it's I/O bound. Almost no applications are CPU bound in today's world. Very, very few. Unless you like computing weather stations or trying to simulate a nuclear explosion or something crazy like that. Your app, especially your business app, is I/O bound. So one of the things that the unit tests do is they remove all of the I/O. That means that you can execute literally thousands upon thousands of unit tests in under a second, right? Your whole application can be tested in under a second if you do it right. That means that you can execute those tests on every time you hit save in your IDE. So if you have your IDE, you can set it up so that every time I hit save, all my tests run. And that completely changes the way you develop, because if you think about what tests are assumptions that you said need to be true for the application to work, right? And over time, as we're building applications, the number of assumptions keeps going up. And so by executing all these assumptions all the time, you're basically saying, if I'm going to change this little thing over here, am I breaking any of the previous assumptions? And normally, we don't do that, right? Normally, we just think about the problem really, really hard and say, well, I think I'm going to be okay. Then we build the application, throw it over the fence to the QA team. 2 weeks later, they run all the tests manually. It takes them a week to do it. And they say, oh, all of these assumptions are broken. And now we have this big problem of not knowing which things that you've changed broke the assumption. Because, you know, over the period of 1 week, you have changed lots and lots of things. And so now you have this search problem of figuring out what that you have done has actually broken it. Now, if you could verify these assumptions all the time, and every time you hit save, what that really means is that if you break your tests, instead of opening up the debugger and trying to figure out what went wrong, you hit this magical key that's on your keyboard. You know what that is? Apple Z, or if you have a non-Mac computer, it's Control Z, right? It's undo. You save, oh, it's broken. You know, I didn't expect it to be broken. Instead of opening up a debugger, I'm going to hit Apple Z, undo what I just did, save it, it's green again. Let me try it again, but this time in the simpler steps, right? And so your development changes from hack, debug, debug, into hack, okay, nothing's broken, hack some more, nothing's broken. And if something is broken, just back up a little bit and try again. And it fundamentally changes the way you write code. So basically we have this progression that we started with large tests and we're slowly going to smaller and smaller unit tests. Now don't think of these things as buckets, like there's this bucket, that bucket, and this bucket. It's more of a continuum, right? The tests, there's no hard lines or boundaries or like real questions. The way to me, what makes a test small is that it's very fast and has no I/O. If those two things are true, then a test is fast because I can execute all of them. And so I really separate my tests into super fast tests that I can run all the time and kind of slow end-to-end tests that I usually run at least once a day. And certainly I run them as part of the continuous build. You all do continuous builds, right? More hands need to go up. So this is kind of how it should look like. So if you think about it, at the bottom you have number of tests, on the left-hand side you have the amount of time it takes to execute. And so the unit test is the stuff that I absolutely love. I think this is the bread and butter that you guys should do. For an application, for example, the app I'm working on, Angular, we have about 1,600 unit tests in this category. And we also have scenario tests, but we only have about 100 of them. Our 1,600 unit tests take under 3 seconds to execute in the real browser. And our scenario tests take about 2 minutes to execute. So that's a huge difference, right? These guys, I can run them on every save of my application. Those guys, well, I usually run them before I commit. It's not something I do all the time. And so this is what you should be guided on. And my point is that when people first start writing tests, this pyramid is upside down. They have a huge number of scenario tests and almost no unit tests. And this is when they suffer, when they say, oh, testing is BS, you know, it doesn't work. It's a lot of work and very little benefit and so on. And so I want you to think about how you would test a flashlight. So you can test the flashlight in 2 ways. Before you build it, you take all the components and you do a small unit test. You test to make sure that batteries are charged. You test to make sure that the switch works properly. You test to make sure that the light bulb does not have a broken filament. And these tests are super cheap, as you can see in the table. And if the test fails, you know exactly what's the problem. Oh, the battery's not charged, we grab a different battery. If the switch doesn't turn on and off, or it's constantly stuck in one position, you know what to change. On the other hand, if you do the end-to-end test, which is the flashlight is built, and then you turn it on, and it doesn't come on, you have no idea what's wrong. First of all, it's very expensive to run such a test, as I explained earlier. But the more important thing is, once you know that it doesn't work, you have no clue where to start. You can just randomly like replace parts to kind of figure out, is it this, is it that, which one is it? But the flip side is also true that if the flashlight turns on, you have kind of like, yeah, okay, it seems to be working. And so the way I think about it is, when you're building a car, right, there's this ultimate end-to-end test. And the ultimate end-to-end test that they have at the car factories, they take the key, put it in the ignition, start it, and they drive it to the parking lot. And if they can do this, the next step is they'll sell you the car. Now, there are times when they put the key in, and they turn the key and nothing happens. And that's the time where they pull the car over to the side, and then they have people to debug it. But the reason they can get away with this is because they have lots and lots of steps beforehand. Like, they have lots of essentially unit tests before they even get to this point, which verifies that the battery is charged, that the engine is proper, that the brakes are properly installed. Like, they have tests all along because those are the common failure modes they discover. And what happens is, when they put the key in and nothing happens and they pull the car to the side, the people who debug this also keep track of what's the common reason for this. And if they, for example, discover that a common reason is, I don't know, somebody forgot to tighten the screw on the battery terminal, right? So there's no electricity going to the starter. If they discover that's the case, then they go back to wherever this thing is being installed, and they make a little test over there and say, okay, before you put it to the next station, I want you to verify that this screw is tightened. Because by you spending a fraction of the time verifying that it's tightened, somewhere down the line, over there in the corner, the poor fellow doesn't have to like spend hours trying to figure out what's going on. And so this is what happens in software development as well, is that when you write unit tests, you're never going to think about all the corner cases. It's just not going to happen. But so here and there, your end-to-end tests will fail. Or better yet, sometimes you just get a report from the outside world that when you do a fault analysis as to what was the problem, you can go back and you can write an additional unit test and say, oh, from now on, I can also test this extra thing. Let's talk about dependencies. So there's lots of different kinds of dependencies, and I'm not going to go through all of them. By the way, how am I doing on time? 15 minutes to go? Okay. So this is what a test looks like, right? You got your unit test, you got your class under the test, that's the blue. The unit test applies some stimulus, and then assert that something is true, right? You're full familiar with this? That's such a simple picture. Why are we even having this meeting if it's so simple? What's wrong with this picture? Right. If this was what would make testing, then this would be super easy. So for example, the class under test over here, something like math absolute value. Would anybody in this room have trouble writing a unit test for math.absolute value? I hope the answer is no. Right? But that's not what the world looks like. It looks more like this, where the class under test has dependencies, and it gets worse. Those guys have dependencies themselves. And so really, this is the world you're testing, right? You have these complicated things that happen behind the scenes. In order to make testing possible, what you gotta do is you gotta look at all the dependencies and say, not all of them are the same. Some have I/O, some are expensive in a lot of different ways. It doesn't matter. The point is you look at this and you say, I want to get rid of some of these dependencies. And so in order to do this, you need to have what I would call a seam after the class under test. And seam is basically a fancy way of saying, I want to have the ability to replace the dependencies in the test with friendlies. Now what's a friendly? Friendly could be one of two things. It could be a mock. Everybody knows what a mock is? Or it could be the real object just configured differently. So for example, let's say one of these things is a cache. In order to simulate, in production, you're going to set up a cache and you're going to set it up with a million buckets of caching space. But that makes the test super hard because if you want to cause a cache overflow, you got to put a million things into it, right? Wouldn't it be much better if I created a cache with size of 1? Then I can simulate all kinds of interesting things relatively cheaply. So I'm using the real object, I'm just configuring it differently, right? That's why I'm calling it friendly, because it's collaborating with me. And sometimes what makes the testing with these friendlies easy is just simple fact that I have a reference to it, right? Because I can look and peer into the internal state of the system. So if I am the one who instantiated the cache, That means I'm also the one who has a reference to it, and I'm also the one who can pre-populate the cache. I'm also the one who can clear the cache. I can put bogus items in there. I can cause overflows and so on. And so I basically can team up from both ends and test the guy in the middle. Now, there's three kinds of errors that I've drawn over here for you. There is the guy with the dot, no dot, and no dashed object. So the guy with the dot is basically the new operator, right? If I have a dependency, I can instantiate it using calling the new operator. I can also get call my dependency because I got a reference to it from somewhere else, from outside of the class itself. And finally, I can just reach into the global space of the application and magically pull a dependency out of thin air. This is basically your global state. And sometimes you feel better if you wrap it in a singleton, but it's really the same exact thing. You're pulling a dependency out of thin air. Out of those three dependencies, only the middle one is friendly to us because we get to control it. We don't get to control when you call the new operator, and we certainly don't get to control the global references because usually singletons are written in such a way that once they're instantiated, they cannot be replaced. Right? That's kind of the whole point of a singleton, which makes it the test super hard to manipulate. So the name of the game is, how do I replace your dependency with the friendlies? And the only way to do that is to look in at the class under test. And normally if you look at a class under test, it has two parts. It has a whole bunch of if statements, that's your indentations in the flow of code base, right? And then there's a whole bunch of how do I get my dependencies, usually in the form of new, singleton lookup, or getting them from outside world. And I want you to do this. I want you to break it. And I want you to have the simple rule that basically says, my class is either in the business of being a business logic, which means it has lots of if statements, loops, and all the other magical things that make code, or it's in the business of object graph construction or lookup, in other words, a factory. So on the left-hand side, you have all your new operators and your lookup stuff. And the right-hand side, you have all your if statements and while loops and so on. If you break your code up into these two kinds of objects, and that the two shall never meet, then it turns out what you can do is this. If the class under test presumably is business logic, right? It has lots of loops, if statements, and so on. That means it has no new operators. It means that all it's doing inside of the constructor is saying, I need A, B, and C to get my job done. And because you're in the test and you're instantiating the class under test, you get to see what those dependencies are. And because you get to see them, you can either make the real stuff, but configure it differently, or you can make a mock, or you can even pass null, for example, by saying that, hey, it doesn't matter, for this particular test, you don't need this dependency, it's irrelevant. You know, this is not the class you're looking for when things go haywire. So it's kind of the theory. Let's do some hands-on examples. So our job is going to be to write a test for this particular class. And again, how many of you are trying to understand it? Ooh, much better. Okay, knock it off. I didn't say understand this code, and I also didn't say, well, I did say, so what I said was wrong. What we're going to try to do is we're going to refactor it for testability. And before we refactor it for testability, I'm going to show you how difficult it is to write a test for code in this stage. So this is the case where there's a bunch of software engineers who go and implement stuff, and they'll end up with something like this. And then a bunch of test engineers are supposed to go afterwards and write automated tests. This code was designed to slap you around. I have taken years of experience of seeing horrible code, and I have all squashed it down into that one class. So everything I can think of in terms of what makes code hard to test is in there. We have global state, we have law of limiter violations, we have global references to things, we have hard-coded the new operator, and I have completely removed any kind of dependency injection. So, and we're going to make another assumption that is common, is that once the code is written, people have this natural aversion to changing it. Like, it's written, it works, don't touch it, right? And this is what makes the test hard to write, because A, it's after the fact, but B, it's like you're really afraid to touch the code that you've spent so many hard hours trying to make them work, right? So like, don't touch the code. Now, when I look at code, you know, as I said, after a while you kind of develop certain things you look for, and this is kind of how I color code my code in my head. And this is what I look for. I look at the constructor, and I say, hey, does the constructor, in this case config, match the fields inside of the class? And the answer is no. And so I look at anything going inside of the constructor, and any time I see a dot, which means it's a dereference, whether it's to a field or whether it's to call a function, to me that's a red flag. So as you can see, the whole constructor is troublesome as far as I'm concerned. Anything static on the top is also troublesome, and I'll show you how all this stuff comes into play. So let's talk about the dependencies, right? So in your class, you need to specify, let's say, certificate, username, and password. And notice the constructor doesn't say I need certificate, username, and password. What the constructor says, I need this general object called the config. Like, I'm sure you've done this, where you have this config object that you pass around, it's everywhere. And so notice what happens inside of the test. In order to, let's see, where am I? Oops. It's not even here. It's actually a two-page thing. So in order to make a config, which is this guy over here, I need to make a user, because notice it says config.user, right? There's a user object in the middle over here. And a user then gets set username and password. Now I'm making a crazy assumption over here for the purposes of this talk. And that is, I am making this crazy assumption that the class I'm about to test is super hard to test, but the rest of the system is all friendly towards testing. But that's never going to happen in real life. Like, if this class is screwed up, chances are every other class is screwed up too. Which means chances are extremely good that I won't actually be able to say new user, because that will have some crazy set of dependencies that I won't be able to satisfy, right? So even in this simple example where theoretically I could make a user, 5 minutes to go. Well, in that case, we'll speed up a little bit. I will have to do all this crazy stuff. So, in the interest of time, notice I have more stuff to do, and I have to start a server. If there was something like a singleton, let's see. See, this is the syncer is a singleton, so this setup only has to run once. So the point here is, you go through all this stuff, and you basically written 2 pages of code, and this is all the code you've written in order to get to the constructor. We haven't even gotten to the test. So the test will look something like this. Now here's the problem with this test. As it says, test sync. And it tests something, but you have no idea what's actually being tested. And the reason for that is because humans are really social animals, right? For millennia, we were sitting around a campfire telling stories to each other. And so our brain is really good at remembering stories. And the trouble with this test is there's no story here. So I'm going to fast forward over here. And I'm going to say, forget tests. Tests are so yesterday. Let's talk about executable specs. What's an executable spec? Well, let's check a test with a syntactic sugar, and sugar makes everything test better. So just by changing the way we look at this particular problem, all of a sudden it's going to make a lot more sense. So let's flip this thing around, and let's say we're going to write test first, and then we're going to write the implementation. But more importantly, when we write test first, we're going to tell a story. And these are some of the stories you can tell about the object. You can say, well, it should sync message from Bob since last sync. Like, that's a story I can relate to. It's not just test some method X. It's a story that I'm going to tell you and I'm going to take you through. It should close the connection even when exception is thrown. Well, I get that. Like, I understand what you're trying to do, and so on. And so all these things are stories that we can discuss. And so your setup basically looks like this. You're going to instantiate things like dates, like for example, long ago, now. You can instantiate objects, filters. Notice there's no global state. And notice that the test is simply instantiating things. To make unit testing easy, you have to really think about how do I make just about any object in the system easy to instantiate. Because inside of the test, you can instantiate things over and over and over again. And so if you can make instantiation easy, everything else is going to follow. And this is what a story for this particular thing would look like. So it should close the connection even when the exception is thrown. Oh, I get it. I'm going to make an exception. I'm going to make a fake filter called exception throwing filter. And then I'm going to make a syncer. And then notice I pass a whole bunch of nulls because those are really relevant for our discussion. So if this test fails, it's a hint to whoever is reading it that don't even bother looking at these objects. They're not part of this test. And then I'm going to write a test that basically says, do a sync. you know, and then expect an exception. So we assert that a particular exception is still thrown. And so the thing I'm trying to tell you is that if you structure your test as stories, then people kind of understand the gist of it. They understand what you're aiming for, and therefore they can write it. Now, it's not that there's one set of people who write tests and another set of people that write implementation. It doesn't work that way. It's a repetitive process, and the two people is the same person. The person writing the test and the person writing the implementation is the same person. It's just, he's got a little bit of a, what's the personality disorder called when you have two people in one? Schizophrenia, yes. He's got a bit of a schizophrenia, right? And so you got to make sure you don't get ahead of yourself. Anyways, this is what the implementation of this thing might look like. The important thing here is that we have all the dependencies, and we have removed all of the new operators. There's still new data over there, but that's a value object. You don't have time to get into it. It just kind of makes it okay. But the point is that this is testable. This is something that you would end up with if you did it the other way around. And really the only difference between this and what we started originally is how the dependencies got into the system. This is what a good constructor looks like. If I see a constructor like this, I'm happy, because I see that everything that you ask for is directly passed in to one of the dependencies. As a matter of fact, there are new languages that are simplifying this whole step, where you can actually list the dependencies in the public class definition, which kind of, they realize that this is the perfect constructor. I think that's it before. So, sorry, there's a portion of the presentation that I didn't get a chance to talk about, but I'm sure you guys have questions. Yes, back there. In your current project? What's the way out? Okay, so you're basically saying, I have a project that's screwed up, it's complicated, all of these things you said not to do, it's all in there, how do I fix this? That, unfortunately, is a very difficult question to answer. The way out, the honest way out, is that you need to have somebody on your team who really understands testability. Okay, so you have to get an expert on your team first. And what the person basically says is, he says, all right, the trick to the whole thing is breaking up dependencies. So you want to get stuff like dependency injection into the system. So things like juice if it's a Java project, or whatever they call it in your project. And then you want to start at a class and just refactor the single class by pushing the dependencies out. And then you want to commit that and repeat and rinse and repeat until the whole system. Now this is a hard undertaking that takes a long time. And that's why you have to have the expert who understands testing, because that person really has to say, oh, this is the vision where we want to get to. And then he has to make sure that everybody is heading towards the thing. This is what I used to do in my previous life when I was in Google. It takes months to change people's opinions about this stuff. This is not something that can happen overnight. And it's a collection of tricking people into doing the right stuff, and also doing something like this. So this is visibility into the world. This is one of the charts that I used to do, which basically shows that each bubble is a commit that you do. This is time. The axis on the left-hand side is what percentage of that commit was test and what percentage was production code. The size of the bubble is the size of the check-in, and the color of the bubble is the particular person. Now, this graph can be misinterpreted, so it's kind of dangerous. But notice that there's this general trend upwards, right? And so this is basically how we knew on a project that we were making progress, is because there were fewer and fewer commits that happened in the low space, which means no tests, and more happened in the upper space, which means tests were being added. So visibility is another big important thing. And it turns out when you have something like this, you can play games. You can give people rewards, or people just like playing games, right? I hope that answers it. Anybody else? Yes?
So I have a question. Is it possible to write some tool that could rename everything in my project then force me to write those tests and then rename back. Because I can imagine writing a tool that renames into those smaller things, but renaming
Yeah, so that tool is called IDE. Right? And IDEs are already pretty good about this, but this problem we're facing is not a problem of renaming things, it's a problem of structure. And IDEs, when they do refactorings, they do that's not the right word. They do refactorings where they change things, but it's the same exact thing. What you want is you want to change things to be different. And so while IDEs are super helpful in refactoring, fundamentally there is no automated tool to get you there. And I think we're out of time, right? So thank you. You can catch me outside if you have more questions.